Hey everyone, welcome to my channel. This is a new type of videos for the certification process. So as of now, we are gonna deal with the Databricks certified Databricks certified developer using Apache Spark. The specification is Python here. So let's see. Let's go further. Okay, so yeah, in this case, in this thing, we're gonna deal with this certification, which is a Databricks certified associate developer for Apache Spark, and the syllabus I have mentioned in the description. Um, so it's architecture related stuff, and it will be 20%, and Spark SQL it will be 20%, and DataFrames API application 30%, and DataFrame API performance tuning is 10%. Structured streaming 10%, and Spark connect to deploy applications that is 5%, and rest of the details you can find it in the website. I'll try to give the link here in the description itself. um, 1 minute, let me paste the description. Okay, I have updated this. Yeah, so let's go ahead, and it gave some information about basic information about the exam. Let's close this. So yeah, so the registration fee would be $200, and 90 minutes would be the exam time, and it will be around having a 45 questions in that. Instead of going in that page, there is a self-paced learning environment that will be given by Databricks environment, where in this case here, you can see there was a learning festival happened on 9th January to 30th January 2026 happened, and there will be another one in future. If you participate in this, and if you complete any of the training, like there are multiple trainings here related to the certification, which is associate data engineer. One minute, let me check my volume. I'm sorry, I think maybe volume is not very audible, or I'm not sure, but as of now. But yeah, I was just explaining about the examination perspective. So what are all the way we can prepare and to get ready for the different certification exams in related to Databricks. So for example, data associate data engineer, professional data engineer examination is there, data analyst examination is there. Same way, associate ML practitioner, professional ML practitioner, generative AI engineer, Spark developer, and also warehouse practitioner. The few levels of certifications are there, so you can find that information in this, and I'll try to update this learning festival link as well. But it will be end. It is ended already, the learning certification, because it will end on 30th January. Um, so now we need to wait for the next available learning journey with the Databricks. So if you finish this, they'll give a discount coupon of 50%. So with using that, you can able to register the exam in $100 only. So that's the help I could do here. Apart from that, yeah, apart from that, let's continue the learning with the help of whatever the material they have provided. I'll try to keep this little short, and even though if the videos are there, I'll play them, and I'll try to make you guys aware of it. So let's see. Introduction to Apache Spark, and this is what the initial lesson. So let's continue with that, and oh, once this is done, I think there are some more phases of this is there, and the course introduction will be there here, and I'll skip more the unnecessary videos here. Like this is a course introduction, what it gonna teach in this learning journey. So I'll just avoid those things, and apart from that, I'll try to do some important aspects like this is the pre-introduction for the course, and of course this is the introduction information about the course, and I'll try to show those details as much as I can. I'll retake the lesson here, and in that, so what are all the objectives? Okay, let me maximize this, and I'll try to read out these lines, and I'll try to give a basic information about the first lesson, which is Spark runtime architecture, what it is exactly. So yeah, let's try to read step by step, and I hope you understand the pattern of this particular training. So let's see. Let's go ahead. So lesson learning objectives: identify the roles of the driver, workers, and executors in Spark applications. Under the role of the Spark driver, learn how Spark session serves as a unified entry point for Spark application. Understand how worker nodes execute tasks, and how resources are allocated within Spark application, and utilize the Spark UI monitor application progress, and DAG visualization, and resource allocation. This is the main, and the subnotes has here, like by the end of this lecture you will be able to describe the runtime architecture and the different roles within a Spark application, including the driver, workers, executors. Explain the Spark driver and Spark session as the entry point, and understand executors and resources management. Describe how tasks and works are distributed, and visualize a Spark application at runtime using Spark UI. So this is the main motive of this particular lesson. Let's go to the next page. What is Spark? And we already know that it's a distributed framework to run jobs, to provide data engineering in an effective manner. Okay, so unified large scale data processing and analytics framework. So data processing and analytics framework we need to remember, and Apache Spark. If you have a prior experience about data engineering, then you may able to understand these things pretty well. And if you are not able to get things, like you can comment me here, and I'll try to answer those questions. Like next, Apache Spark is an open source distributed unified analytics engine for fast and large scale data processing. Since it is a distributed and open source, it is widely used. So distributed computing, you already aware, like small machines acts as different machines, and it will try to process whatever the task you have generated. It will have a connectivity between them, whatever the framework is designed on top of it. Okay, so features, native support for SQL, because if you know SQL, I mean, you can able to use Spark SQL in that, and with just directly writing the queries, most of the operations can be performed. SQL and streaming data and machine learning. Streaming data is for the continuous process, like uh, where the data is keep on generating, and it needs to be processed immediately without any delay, like banking transactions and all. So for those things, streaming process is pretty important. And machine learning aspect, and if you want to do go model levels and create models, and deploy those models, and try to automate your work, so then that's machine learning. And graph processing through a consistent API. So there is another programming level as well for this, and if in future we may learn. So let's see. delivers high performance through in-memory computation, making it significantly faster than other processing frameworks. Because of in-memory framework like RAM, it will random access memory. It will everything. It's a big in-memory, big memory will be there, and in that only the processing will happen. So that's it. And after that, operates seamlessly with driver data sources, including cloud storage. Any it can interact with any other cloud as well, and local files and other databases as well. So it has a wide variety of tool support available. So that's why you can incorporate anything in it. So Apache Spark is a unified analytics framework, providing a consistent interface for handling big data across multiple domains. It is open source and distributed, built for large scale processing and horizontal scalability. Yeah, it has a native support for multiple interfaces, including SQL, streaming, machine learning, graph processing, and more. It is designed high performance, built around in-memory processing, which is significantly faster than disk-based systems. If it is a disk-based system, you need to write to the disk, you need to retrieve to disk. That will be another extra operation. But if the data is in memory, then it will be easy to quickly process all those stuff. That's the best advantage of Spark having systems that proceed that proceed. Okay, it it seamlessly integrates into cloud environments, yeah, enabling reading and writing and for cloud storage, different type of storage systems, and any other local or DB or any cloud environment you can able to connect. So that's the best feature to utilize Spark. So next is the usage of Spark mentioned here, like how it is in started and how it's elaborated its wings to different areas. So in the Databricks level, Spark and Databricks collaboration, how it happened, though, and that thing is mentioned here. Like let me maximize it more. And 2009 it started, and now in 2024 Databricks tablet. So all those other new stuffs added step by step in the using the Spark environment. So that's the advantage you have when you work with this tool. Okay, so Apache Spark oriented in 2009 at UC Berkeley's AMP lab, a research lab at UC Berkeley. Spark was open source in 2010. In 2013, Databricks was founded by the creators of Spark, and the Spark project was contributed to the Apache Software Foundation. Spark becomes the top level Apache project in 2014. Since then, Databricks has continued a drive Spark's development. Means it's a layer on top of Spark environment. Databricks is a layer on top of the Spark environment, built on top of it, and utilizing the all the usabilities of all the features of Spark. Okay, so key features like DataFrame API, structured streaming, Delta Lake, and ML Flow. Today, Databricks remain primary contributor and enhancing Spark with innovations including adaptive query execution, Unity catalog, and more. So let's continue with that. So let's minimize it and elaborate it a bit. And okay, this is the image. Spark components like this is the basic architecture of Spark, and core API would be the RDD API on top of the DataFrame API, which supports multiple languages like Python, Scala, Java. Python, Scala, Java, same way. And on top of that, there are certain new components like which is structured streaming API and regular processing as well. Spark SQL and Spark R API for the R programming language, and for M library for Python and Scala Java. And this architecture will explain the basic infrastructure, how different features and components are built together in Spark environment, and then the Databricks as well. Okay, next. Let's continue with this. Apache Spark runtime architecture. It's like client will be there. It will request for a particular job, and particular client will initiate something here, and the driver will take that particular responsibility, and it will move it to the cluster manager. Cluster manager will having some internal parts like master, and these are slaves or workers, you can say. So master slave architecture, it is needs to be it is there, and driver will help to coordinate all those things, and driver will, with the help of cluster manager, it will submit that particular thing to the cluster, and cluster will take care of which worker and the corresponding executor it needs to take, and it has tasks. Executor will have tasks. um, Executor will have tasks, and on top of that there will be workers, and it will be having some cache memory. So in this way it will organize one after the other, like, okay, let's read through these things. And driver, the brain of the Spark application, responsible for planning and coordinating execution. I already wrote the exam, so this architecture level questions will be there, like who will do what. So that's why we need to remember this part. The brain of the Spark. So driver is the brain of the Spark application, and what is its responsibility is planning and coordinating. Planning and coordinating. Here, if you see that client submitting something, and uh, this is giving Spark session and Spark context, and it starts planning with the help of the cluster. Whether if cluster is not there, it is in a local mode, it will do in a local mode itself. Instead of cluster in the same machine, it will continue processing that thing. So driver is a brain, and these are the some other body parts. Okay, so cluster manager slash master here manages cluster resources and allocates them to the driver internal. Hmm. Yeah, so manages cluster resources. Like for example, whatever the resources it has in the cluster, any how many workers are there, how many executors, how many cores it has, and all those other stuff it will manage. So cluster manager, cluster manager or master manages cluster resources and allocates them to driver. This thing we need to remember. Workers nodes in the cluster that host executors. Okay, these are the workers, and it will host executor, and executor will have certain tasks. Executors process on worker nodes that execute tasks assigned by the driver. So driver, with the help of cluster manager, get the uh, corresponding resources, and it will assign some tasks, so that task will be performed by the executor. Executor is the end labor, like who will work on those things. Okay, and it will differentiate, it will define that particular whatever the work given in task or subtask or whatever, and with that it will perform those things. Okay, the driver is the central component that manages the application lifecycle and execution. The cluster manager allocates resources and assign tasks to workers. On Databricks cluster, this component is managed for you. So whatever the internal process here, right, and the Databricks, it will be managed by the Databricks engine itself. Workers perform the task assigned by the driver, execute code, and return results. Okay, executors run on worker nodes. The question may come, like, where the executor can work. Those are done on worker nodes, and there will be a master for each worker. Okay, and handling task execution and cache data. Okay, this is one thing. And mm, next is the Spark driver. Spark driver, planning, coordinating, and task execution management. So each one will be explained. Create the Spark session, means the session, whatever the current uh, job needs to be performed end to end. First, the session will be created, it will be triggered. The entry point of the Spark application for sure, and you can put an application name. You can use that application name, do some check operations or all the other stuff in the internal programming. Okay, analyze the Spark application and constructs a DAG, directed cyclic graph, is the planning type of a thing. So where it will show in the Spark UI that will have a detailed information about from where it started and where it end. So that thing will be there, like analyze the Spark application and constructs are directed at who will construct that. It's a driver construct the DAG. Okay, so that we need to remember that schedule and distribute tasks to executors for execution. Driver is the responsible for, even though it had to take the help from the cluster manager, that to just to allocate the corresponding executors. So then executors are once executors are available for the driver will try to put those tasks. Of course, it will, as per the DAG, it will differentiate, distribute it will separate the tasks and it will distribute the tasks to the corresponding executor for execution. Monitors the progress of tasks and handle failures. Yeah, it will monitor the progress of the task, of course, and after that, if there is any failure occurs, that will be handled by the driver, Spark driver itself. Return results to the client. Okay. Now manage the application lifecycle by creating Spark session for communication with the cluster. Analyze jobs by constructing a direct acyclic graph for processing. Schedule tasks by distributing work to executor. Monitor progress and handles failures to ensure fault tolerance and efficient resource use. Okay, returns results to the client. Ensure end-to-end data processing. Okay, so next, Spark session responsibility. Okay, what is Spark session responsibility? We'll see here. Okay, so Spark application entry point, introduced in Spark 2.0 as a unified entry point for all contexts, firmly. One minute. Introduced in Spark 2.0. Before that, it was not there. Spark session, unified entry point for all contexts, formally instantiated individually as Spark context, SQL context, and Hive context and streaming context was there in the past. So now that everything collaborated together as a Spark session will take care of based on the definition whatever you have given, and created for automatically your Databricks as Spark. So in the Databricks environment, it will be Spark. Okay, you can just say Spark equals to Spark session dot builder. If the code you can see, you need to remember this thing, like we need to import the corresponding session. PySpark SQL, through PySpark SQL, it will support PySpark programming. From PySpark.sql, import Spark session. Spark equals to Spark session dot builder. Application name. This is an application name, like where you want to perform on some. You need to call back this application or something like that. The app name will be helpful. Next, config. Mm, Next, config equals to the configuration for this, like spark.sum.config.option. So this is the file where the entire session will run. Any configuration variables or configuration parameters you need to specify here, you can specify here in this thing, and some value. Each option will have some values, like okay, and get or create will help you to, if this application is already there, it won't destroy that application, and it will just take that application into consideration. But if this application is not there, like based on the app name value here, whatever you specify, and if it is not there, it will create that. So that's the way it will work, and created for you automatically in Databricks as Spark. So Databricks will create internal session for that. Maybe you just specify the application name. That application name can be used for various purposes, like to call back or to rework on those things, or to do some operations, to add some operations, to perform on top of some other operations. That can be done here. Next, unified entry point. Yeah, this is we already know. Let's go with Spark IO. This is the main thing we need to understand, like since it is an in-memory operation, disk IO is very crucial, and so that we need to have a good understanding that executors task execution and IO, this is the main thing of the executor perspective, because this is the end labor, like where it will work, it's an end worker, so where it will actually perform the operation end to end, and it will create actually execute the operation and give the results to the cluster through driver through cluster. So run on worker nodes in a Spark cluster and host tasks. Yeah, different tasks will be hosted here for IO and processing. Each worker node can run multiple executors. Yeah, worker node can have multiple executors for sure. That's correct. With the number depending on available CPU cores, yeah, number of cores available, number of resources available, memory resources, like which is spark.executor.cores, spark.executor.memory, executor core and executor memory, we need to remember. Configuration settings depending on, so that's what the configuration we were working about, and we were talking about this in the previous session, like this is the configuration variable here, and it will be a file and it will have some values, or you can just add more configs. Config, for example, you want to add 10 cores, 10 cores here, like config, again you need to mention another variable, and provide corresponding value. That way you can just navigate this. Okay, and after that, configuration settings, just a second. Sorry for the break. Yeah, so store intermediate and final results in memory or on disk. So the executor responsibility, we need to understand each and every responsibility. There will be some questions on the responsibilities perspective as well. So store intermediate and final results in memory or on disk, that will be an executor task, and interact with the driver for task coordination and task transfer and data transfer. So this is the main responsibilities of executors. Let's read one more time in this way. Okay, task execution and IO handle data processing, IO handle data processing tasks, and communication results back to the driver. The main responsibility is task execution, and IO handle data operation, IO handle data processing task, and communication results back to the driver. This is the main responsibility. Executors run on worker nodes, with each node capable of hosting multiple executors. Resource management is configured through settings like Spark executor.core, Spark executor.memory. Okay, executors can store intermediate and final results in persistent storage. Okay, they interact with the driver by processing assigned tasks and reporting status. So the interaction between executor and driver will happen like this. I hope you got an idea. Now let's move back, and this is the DAG functionality. If you see in a simple manner, so the Spark DAG, directing acyclic graph. So if you see, these are the stages based on the shuffle. It will differentiate these things into different stages, and each stage will have certain amount of tasks. Okay, Spark jobs are broken down into stages. So stage 44, stage 45, stage 46, stage 47. Groups of tasks that can be executed in parallel. Yeah, in parallel, groups of tasks. If there is any op- coordination between these two, it will the shuffle will happen, and it will perform that operation. Okay. Computation flow in one direction through the stage. So it will be from here, it will start here and it will go like this and it won't come back again. Okay, something like that. Okay, computation flow in one direction through the stages. Only one direction it will happen. Okay, stages never loop back. They never loop back like this. It will just go from stage 44, 45, and then 46 and 47. Okay. Mm. So directed, that's the reason it's directed in one direction. And acyclic, never loop back. Acyclic, never loop back. And stages are organized into dependency graph for execution flow. So dependency graph will be there, like for example, if there is any dependency here, it needs to, dependency graph is here, and once it is done, it will go to next level, something like that. Stages are organized into a dependency graph. That's why it says directed acyclic graph. Okay, so need not to read this one. Okay, next, Spark application execution, like, let me see. Okay, Spark application execution, like Spark application will define into some jobs, and jobs will be differentiated into stages. Stages will have tasks. So this is the flow we need to understand. They might ask the questions on this as well. Tasks within a stage run in parallel, known as shared nothing. Stages will run in parallel. Tasks may have direct interaction with the. Okay, we'll talk about this later. Tasks within a stage run in parallel, known as shared nothing mode. So tasks cannot share anything between, but the stages can share between. So tasks cannot share anything. So share nothing way it will execute. So Spark application, job, stage, task. Spark application, job, stage, task. Okay, that's the thing, way we need to remember. Jobs are high level operations triggered by actions in Spark. Of course, we already learned a bit about in the Spark session. mm, Spark session. So actions can trigger some operations here, and such as collect or any save stages. Stages divide jobs into smaller dependent, like for example jobs, and then divide into parts. Stages, tasks are the individual unit of work run in parallel, of course, and tasks are the individual unit of work by executors. In parallel execution, tasks within a stage run independently using shared nothing architecture. So nothing can be shared between tasks, but stages share that information in between. Okay, next is Spark UI, that visualization of the Spark application, where Spark provides web user interfaces for monitoring and management, including application UI per application. Application progress and task execution. Application progress and task execution will be there. DAG visualization and stage details. Okay, application UI per application. This application UI will be per application. Application progress and task execution. DAG visualization and stage details, and resource usage and performance metrics. Okay, what it will do? 1 minute. Spark provides web user interface for monitoring and management, including application UI and master UI. If it is an application UI, it will be per application, application progress and task execution we can see, and DAG visualization and stage details, which stage it is in, resource switches and usage and performance metrics, everything can be used in the application metrics. Per cluster, it's a master UI, worker node status, and health and cluster wide resource allocation. Application UI is there, master UI is there. Two types of UIs will be there in the Spark, that is provided by web user interface. Like in the web URL will be there, and if you click on that, it will go to the certain web page. In that, you will be able to see these two things. Um, in that, you can open the application UI and the master UI. Master UI will tell you about the overall worker node status and the health. The cluster wide resource allocation shows all running applications and available resources. Okay, so this is the use of master UI. And application UI is specifically related to a specific application, like not from the cluster perspective. It will be like application progress and the corresponding task execution, and DAG visualization and stage details, resource usage and performance metrics. So all the other stuff you can see in that. Next, example of Spark UI. If you can see here, there are something like job stage, all the other stuff here, and remaining everything you can just see. DAG visualization, you can see compressed stage, stages, all the other information, even timelines, matrix, and all the other stuff. This is the UI. This is the application UI provided here in this picture. Next, I think cluster. I think cluster it didn't give Spark clusters in Databricks. There are some special case here, like we need to understand. Next, in the Databricks platform offers several options for deploying Spark clusters. Uh, though these include all-purpose cluster, interactive cluster that supports notebooks, jobs, and dashboards with configurable auto termination. Next, job clusters. Ephemeral clusters that start when a job runs and terminate automatically upon it's a configurable auto termination, all purpose clusters, and job clusters are auto termination once the task is done. Optimized for non-interactive workloads. Okay, for example, if you trigger something and it need not to interact anything, then that's why SQL is optimized clusters for SQL query performance with instant startup and auto scaling to balance cost and performance. So these are the three options available: all-purpose cluster and job cluster and the SQL warehouse. So let's read out this. All-purpose clusters are designed for interactive use such as notebooks, dashboard. I'll try to give this URL any which way, because it looks like I cannot play videos due to copyright issues, I believe. So what I'll do is uh, Databricks Databricks training link. Okay, this will help you to go to the link, and this is cert info link. So I kept it in the description so that you can. Okay, so let's come back to the all-purpose cluster. All-purpose clusters are designed for interactive use, such as notebooks, dashboards, and development and support auto termination to save cost. Job clusters are uh, ephemeral clusters created for geometrically terminate upon completion for the cost efficiency. And SQL warehouse are optimized for SQL workloads with instant startup and auto scaling, and support serverless options for high concurrency and cost efficiency. Serverless SQL warehouse provide instant compute without the need of a cluster management. So there are three modes we have, and we can use depending on the need, whatever we have. So yeah, I think so far we are good. Let's see further. So next, I think it is done. So let's close the lesson. Okay, next. So this is a video like it with it that will explain about demo of Databricks architecture here. So we are not gonna show that off. Next, introduction to Apache Spark data frames and SQL. That is the main important aspect. I'll retake the lesson with 18 slides. It is okay. Let's explain those things. So theoretically, I can able to explain that. Practically, I cannot able to show. I'm not sure whether gonna copyright issue will occur. So that's why I wanna avoid that. Okay, next, the lesson learning objectives, understand the uh, okay, this is objectives only, so let's go back 1 second. This is objectives. Let's go to the data frame aspect like yeah, what is a data frame? Structured data processing in Apache Spark. Data frames are distributed collection of records, all with the same predefined structure. Okay, built on Spark's core concepts, but when with the structure optimization and familiar SQL-like operations for data manipulation. Data frames track their schema and provide native support for many of the common SQL functions and relation pattern like joins, like some examples like okay, data frames are evaluated as DAGs using lazy evaluation, of course, until an action triggers, it won't do anything. So basic introduction about the data frames. I think we learned a bit of about data frame little operations in our Spark session, evaluated as this evolution, all the other stuff. Next, creating data frame. So okay, data frames can be created JSON, CSV, Parquet, ORC, text, or any other binary files, Delta Lake, or other table storage format directories. A table or view in a catalog, like Unity catalog, an external database and existing already. Where can we create from? Like for example, like we need to specify a path and df equals to spark.read.csv and the corresponding path. I mean, if you give that CSV file will be read and that is df is a data frame which is created. So from different sources like spark.read.json, spark.read.parquet, spark.read.text, something like that, we can able to read that thing, and schema evaluation will be needs to be specified some aspects, and some default it can be done. Okay, so data frame API optimization, and this is a very important concept, adaptive query execution, that we need to understand. Dynamic plan adjustments, uh, data frame optimizations. What are all the optimizations can be done is like a data frame adaptive query AQE, adaptive query execution, dynamic plan adjustments, cost based optimization during runtime based on actual data characteristics and execution patterns. Depends on the data characteristics of a runtime task, whatever the task is, whatever the task is performing. It's a dynamic plan created to it's a cost based, of course. Next, in-memory columnar storage. In-memory columnar formats or data frames enables efficient analytic query performance and reduce memory footprint. So columnar, it's a columnar operation. So all the things like table type of a thing, and in columns. So the navigation will happen in columns. So that's a better built-in statistics. Automatic statistics collection when saving to optimized formats like Parquet or Delta tables. I mean, if you store it as like this, you will get an inbuilt features like built-in statistics. Enables query planning and execution. Next, catalyst optimizer and photon discussed on the next slide. Okay, fine. So tungsten is Spark's columnar in-memory execution engine. Tungsten, what the tungsten will do is columnar in-memory execution engine provides consistent columnar representation for data frames regardless of data source. Any data source, it will come as a data frame, it will read it as data frame. Tungsten will help to know the columnar format in memory columnar format and the execution aspects. Okay, while data frames always use tungsten's columnar format in memory, statistics statistics are only collected when saving to optimized file formats. Some optimized file formats only can help. Tungsten delivers several performance benefits, including off-heap memory management, hash aware computation, code generation for faster execution, and whole storage code generation. Some tungsten features they given, like tungsten delivers several performance benefits, including off-heap memory management, cache aware computation, code generation for faster execution, and whole storage code generation. It is important to distinguish between the in-memory representation, which is always columnar via tungsten. So the columnar aspect of data frames is maintained by tungsten, and the non-disk storage formats, which may be row based or columnar. Tungsten's columnar format is a key enabler many Spark query optimizations. So Spark has tungsten that will help to a data frame in columnar execution, in memory columnar execution. So that will provide a great advantage of moving through columns in an easy manner. Like for example, the computation, memory management, and all the other stuff. So yeah, this is one advantage we have. Data frame or query planning. Okay. So how Spark will plan its execution, that is very important to understand. Data frame planning. What is data frame plan? Understanding how Spark optimizes and evaluates data frame. Okay, when a data frame is evaluated, the driver creates an optimized execution plan through a series of transformations converted the logical plan into an efficient physical execution plan that minimizes resource usage and execution time. By doing this in this way, the resource utilization and the execution time will be less. Okay, the plan, how it will work is the unsolved logical plan initially started in the analysis phase, and after that analyzed logical plan will analyze, and that internally it will happen, like internally it will analyze and it will create analyzed logical plan, which is logical optimization. Bit of logical optimization happened from the initial analysis to this level, and after that optimize logical plan. Since it is already analyzed and it create a logical plan, in that also it will improve and it will create better optimized logical plan, which is a physical optimization. It is logical and it is physical. Logically means it assumes something and it will create analyzed logical plan, and based on that it will just create some optimized plan out of it. This is a physical optimization, and then physical plan, the actual physical plan comes up. Once the physical optimization happens, then optical, okay, unsolved logical plan will be analyzed, and after that it will create analyzed logical plan. Then logical optimization will happen. That optimized logical plan will be created. That is a physical optimization. Then it will happen physical optimization. Then it's a physical plan created. Then it's a code generation. Next code generated. Okay. Uh, See, the logical plan is analyzed and converted into a physical execution plan for efficient resource usage. This process includes analysis, logical optimization, physical optimization, analysis, logical optimization, physical optimization, and code generation. Okay. Okay. Catalyst optimizer and Python. So query optimization, code generation, and efficient memory management is the main feature of Crystal Optimizer. Crystal Optimizer, a query optimization engine that converts two optimization engines we saw. One is Tungsten, which helps in data frames to generate, yeah, Tungsten to generate this adaptive query execution and the initial plans actually. To the resources allocation and the in-memory execution and memory management, cache awareness, everything it will be generated by the tungsten. Okay, and next this is Catalyst Optimizer, which is query optimization engine that converts data frame operations into an optimized execution plan. Okay, applies rule based and cost based optimizations to improve query performance. So the code performance, whatever you written, that code performance can be improved by the catalyst by query optimization engine that converts data frame operations into an optimized execution plan, and after that applied rule based and cost based optimizations and see what is available, and based on that the best plan it will choose and to improve the performance. Next, Photon engine, Databricks native vectorized query engine that accelerates query execution. Photon engine is related to Databricks, uh, Databricks native vectorized query engine that accelerates query execution, processes data in batches rather than row by row for better performance. Okay, it's internal to Databricks and it will perform by looking the possibilities of batches in that, and that batch will be performed at once, and that will improve slightly better performance than to regular Spark environment. Runs by default on Databricks SQL warehouse and serverless compute. Serverless compute is like whenever you need it, just um, on demand basis you can run. Okay, can be enabled on all purpose and job cluster in Databricks. See, initially we have learned about three things: all purpose and job cluster and the SQL level. Let's see. I think in the previous lesson we have learned. Okay, so yeah, in that it will perform. So this is the responsibilities of Photon engine. Okay, the Catalyst Optimizer converts data frame operations into optimized execution plans using both rule-based and cost-based optimizations. The Photon engine, a Databricks native vectorized query engine, accelerates query execution by processing data in batches rather than row by row. Photon is enabled by default in the SQL warehouse and serverless compute. If you if you use SQL warehouse and serverless compute, it's default. Photon is enabled by default with optional support for all purpose and job cluster. If you do all purpose cluster and job cluster, then it will be optional. So now more on columnar storage, and okay, how the columnar storage will works. That's the explanation it has given. So row oriented. Okay, row and column. Okay. So optimizes data by column rather than row based on efficient scanning and analysis, particularly efficient for analytical workloads. Yes, definitely. On particular columns, you might need to perform some operations and get results out of it. So that's the reason columnar is always better for analytics. Complemented, implemented in data frame internal storage and in a physical file encoding format such as Parquet and ORC. Different file formats these are, and this can be understood. Next, data frame reader. Yeah, spark.read format, so and so in specific format, whatever the format it is there, and after that, from which path it is there, and read from so and so, and yeah, this is the syntax it has given. Data frame reader, of course, spark.read supports multiple formats, provides schema interface. Yeah, data frame writer, flexible output formats and partitioning. Frame writer, of course, it can be partitioned, right? Yeah, can be, and partitioning. So while you're writing flexible output formats, like it can write into different formats, CSV, for KC. Where reading, it's also there, and writing, it's also there, and it will be partitioned so that in a better accessibility of the data. So that's the partitions, it'll do automatically. I think we can specify formats as well, specify partitions as well. Supports various save modes like overwrite, up, and different type of save modes we can use. Data frame schema. um, okay, one sec. Okay, so yeah, so every data frame has a defined schema structure, and data types for all columns. So you can specifyly using like struct type. You can just specify, you can just supply schema by using schema equals to struct type. Start with the brackets and struct field, different fields, and the corresponding data types you can specify. Can be, yeah, can be inferred with and inferred from data, or explicitly specified. Sometimes can be, it will be get from the data, like Apache have schema support. So yeah, print schema will help you to see that particular schema. Self-described formats like Parquet. See, Parquet will have self-description. So include schema information. So that will have, Parquet will have schema information. Okay. So every data frame has a defined schema specifying in the structure and data types for its column. The schema can be inferred from the data explicitly defined for greater efficiency. If you, in real-time programming, it's better to always apply schema. Okay. Self describing formats like Parquet automatically include schema information. A example code snippet demonstrate defined schema using PySpark.struct type. Okay, this is the example it has shown. Next to DDL, data definition language, uh, an alternative to struct type definition. Instead of defining schema using struct type objects, you can use DDL, data definition language, uh, strings for more readable schema definitions. You can do like this. Okay. Schema, DDL schema will have some like name, the corresponding data type, not all name, the field name, and the corresponding type. Okay, null and non-null mentionability mention, that specification can be given. So DDL schema equals to so and so, and equals to DDL schema. Okay, next, structure definition and DDL schema, data definition language you can provide. Okay, next. uh, okay, primitive data types in data frame. These are the list from PySpark SQL types data type, and Spark SQL type, and Python base environment equivalent. So the corresponding thing it has given: byte type, tiny type, short type, small type, int. So this way, I just refer to this later. I'll just leave it for a minute here. Yeah, let's go to the next slide. So data frame data type. So complex data types in this data frame. Data type is array type. Array in Python is a list or tuple equivalent for in the Python. Ordered elements of the same type. Ordered elements of the same type, list or tuple. And map type, dictionary, key value pairs can be different types. So this is the very important slide as well. Like we need to remember like whether tuple in this ordered elements of the same type. It should be same type in ordered format. And this dictionary is key value pairs or different types can be possible. And name fields with specified types. Struct type, struct, tuple, dict, and named tuple. So named fields with specified types. It has some information here. There is also support for complex types such as arrays, maps, and structs. Arrays are ordered elements of the same type. Maps are keys and values that can have different types. Okay. There are these are also support for complex types such as arrays, maps, structs. Arrays are ordered elements of the same type. It should be in order and it should be same type. Arrays. Maps are keys and values that can have different types. Structs are named fields with specified types. Essentially like a table with predefined columns. Structure type. Okay. It's like a structured database. Structured data. Okay. Struct. Name itself is there. You can remember the name. Okay. Next. A reference link is available to view various primitive and complex data types supported in DataFrame API and SQL. Okay. Fine. Let's go to the next. Yeah, until an action performs, until an action is there, then the lazy evaluation will be there. Like once the action triggers, only it will trigger the entire process. Wide and narrow transformations will be there. That I think I already told in my previous and old sessions in Spark. Okay, actions like showing, saving output trigger actual computation. Okay, multiple transformations can be called. The job only creates with an action. Okay, any transformations can be started with action only. So next, common data frame API methods like transformations, select, count, select, filter with column, group by, aggregations. These are all the transformations and actions are count, show, take, first, write. The example. So next, Spark SQL is one of the best feature. You can write SQL queries directly and to, in the Spark in the code, so that it will directly take the and convert it as a data frame. Okay, so SQL interface for Spark data frames like data frame registration, temporary view, and SQL query execution. Temporary views, create or replace temp views. Global temp view is create global temp view. Enable SQL queries on data frame. These are the main things in the data frame. So create or replace temp view will help you to create a temporary view in the same session itself. And if you wanna navigate that session, navigate that particular temporary table to the entire cluster, then yeah, you need to mention that as a our next session. If you want to use this particular temp view in the next session as well, then you need to create global temp view that will be that will be stored somewhere in the internal, so that it will be available from the next session as well. So SQL query execution is uses Spark.SQL for SQL statements, seamless integration with the DataFrame API, full SQL support, complex types and expressions, built-in function library, seamless metastore integration is there. Because it's a SQL is a structured type, right? So structured thing, right? So It'll get schema, metastore, and all the other stuff related information. Okay, data frame registration can be done using create or replace temp view for temporary views, and create global temp views for global views. Okay, SQL query execution allows using Spark SQL to run SQL queries over DataFrame. Seamless integration with DataFrame API enables combining SQL queries with DataFrame operations. This supports complex expressions, built-in functions, and metadata integration through Metastore. Premier and SQL Metastore, like metadata management for Spark SQL. A metastore is responsible for defining table schema and locations, defining table partitions, storing properties and information for object include tables, views, and functions. All these can be supported by SQL Metastore. So Unity Catalog is the centralized Metastore serves. So centralized Metastore serves services provided for Databricks accounts and assigned to Databricks workspaces that enables fine-grained security and governance across all the datasets. Unity Catalog is related to Databricks and Databricks Workspace and Databricks accounts. So it's a centralized metastore for everything. The local metastore for this SQL metastore. Okay, a metastore is responsible for defining table schemas, locations, partitions, and all the other stuff. It stores metadata and properties for objects such as tables, views, functions. Unity Catalog is a centralized metastore serves service centralized metastore service provided by Databricks for security and governance, enabling consistent access control and data lineage across Databricks workspace. Okay, end of this lesson. Let's go to the next lesson. Reading and writing data frame. I'm not going to show this. It's just some actions and transformations and corresponding operations is performed in this execution, so that it will can how to read, how to write, and all those other stuff. So that will be you can just directly go through. You can directly go through this. Next, distributed system programming fundamentals. How the distributed programming can work. I want to just retake this lesson. It will be pretty small. Don't worry, I'll finish quick. Okay, this is first slide would be lesson objectives, and next. So how the distributed computing works here. That's what the information it has provided. Okay. Um, Shared nothing architecture. Independence. Each node works independently and manages its own resources. CPU, memory, disk. Three things: CPU, memory, disk. CPU to process that thing, memory is to storage. It's in memory processing also happens, and disk is to disk storage. Okay, scalability. Adding more nodes can improve performance without resources contention. Fault tolerance. Failures are isolated to individual nodes. And that particular node only it will fail, and it will minimize the system-wide impacts. So when restart, and it will whatever the failure happens, it will take up by the others. Resource partitioning. Data and workloads are partitioned across nodes uh, to eliminate contention. Okay, next let's go. Okay, partitioning. How Spark distributes data across the cluster. So this is the so shuffle is something happened in between. So I think that's what it can mention. Okay, let's read out this thing. Data. distribution. Data divides into manually exclusive, mutually exclusive in-memory partitions. Each partitions will be assigned to, yeah, in an executor, in a worker, in an executor. Okay, partition 0, partition 1 to go to an executor, like here if you see in this worker executor, and the splitted input data will go, each partition will go to one executor. Okay, and default partitioning based upon input can be manipulated. Okay, size and number of partitions affect parallelism, of course. How many partitions it is. Based on that only the engineering will happen in behind the scene, or we'll use some code to make it happen as a parallel execution. Okay, processing model. Proceed each partition proceeded independently. Each partition proceeded independently. Multiple partitions can run in parallel. Processing model is each partition processed independently, separately. It's not like, for example, execution of partition 2 will not have any impact on the process. The resources will be there for this, and that will be taken care here. And here also there will be having some resources. So that's the independent processing, distributed processing, we can say. Multiple partitions can run in parallel. Of course, this partition is running and this partition also running at the same time. So one partition is equals to one task in Spark. Yeah, each partition is each task. Okay, impacts performance and the shuffle operations. Shuffle is the main thing that will differentiate. So shuffle operation, we need to focus on that. Shuffle means like when the data need to be shared between the partitions, that is called shuffle. Okay, so what is shuffle? Redistributing data across partitions is shuffle. Required for operations like group by, means whatever the complex transformations or wide transformations, we can say. Narrow transformations are simple, which can execute in one partition. It need not to have, it need it does not have any dependency on other dependency on the data of any other partition. So then it's called narrow transformations. And wide transformations are, there is a dependency of the data with other partitions. So in those cases, that is wide transformations. Okay, when it occurs, wide transformations, yeah, of course. Key based operations, data operations. Key based operations means join is one of the example, and data repartitioning. Whenever you want to exclusively do the repartitioning with the repartitioning function, so then it occurs. Okay, so map reduce in action. So this is the one of the image, I mean, it is showing how the map reduce will works. Like uh, it is getting some data to process and the input to the data frame. Spark read CSV and so reading as a CSV, filtered data frame, and it is filtering something, some operations like, okay, amount is greater than 50 only we want to consider, for when that data is filtered first, and after that it is going into the map area, where the map area is just shuffling everything and collecting data between all those based on the key. Like it's in grouped by filter data, group by ID. So ID basis it is grouping by, and grouping data. A is coming to one side, B is coming one side, and in one partition, partition two. The data is distributed in different partitions. With the shuffle is happened, since these are in different partitions. Now it is came into different partitions now. So that shuffle is happening, and reduce shuffle, and then reduce stage. Reduce stage, what happens is amount and sum, the aggregation operations will happen in the reduce stage, and it will give the output. So that's the way it will work in a map reduce perspective. And Spark implementation, map reduce at the core of everything, of course. Fundamental pattern, every pattern operation maps to map shuffle reduce. Map shuffle reduce, yeah, every Spark operation maps to map shuffle reduce. Even simple transformations follow this model. This is the model it will follow. Core building blocks for all distributed operations. Common example is group by, map, extract keys. Group by is map, extract keys, and shuffle by key, and reduce, then aggregate. So the same way join, map, prepare key, and then shuffle, co-locate. Like for example, one key is another place, another key another place. So the co-locate and reduces the combine them together. That is filter. Map evaluates condition, no shuffle or reduce needed here, because just a simple transformation, like narrow transformation. So it will just need not to have any shuffling here. Okay, this is a good lesson. Let's go ahead with the next. ETL operations in DataFrame API. What are all the ETL operations? Let's try to learn it. Let's go to the slide number 2, slide number 3, I think. Slide number 2 is having lesson objectives, and after that, slide number 3, DataFrame transformation methods. Like DataFrame operations are distributed automatically across all partitions. Yeah, enabling parallel processing of large data sets, of course. Data comes in, it will distribute to the corresponding partitions, and the performance the corresponding operations happen on each partition, and there it may be combined after that. Okay, all data frame transformations have equivalent SQL operation under the hood. Like example, select maps to select, select maps to select, filters map to where, something like that. Internally it will be an SQL only. In fact, the data engineering itself is like an SQL part only. So next, methods return a new data frame rather than modifying an existing one, supporting immutable transformation. So since data frame is immutable, so it will create a new data frame. Each operation builds upon a logical plan until an action triggers. Action triggered, then the logical plan will be gone and the physical plan will come in, and it will work one after the other. Okay. Next, some example operations it has given, like data frame methods. Select is select here, and filter and where we have where. Group by is group by, order by and sort order by, and join is join here. In the same way, the method combination with SQL functionality, we need to understand that. Next, so handle massive values in data frames. Common functions for handling nulls. Is null, is not null, is the common functions, and count of column. Count non-null values only. That is count of column, non-null values only in specific column. So fill NA is like a replace null values with values. That is df.na.fill or df.fill.na will help you to replace nulls with some other value. If you mention the value as x, that will be the nulls will be replaced with x. Next, to drop na is to remove the rows with nulls. df.na.drop or df.dropNA. Remove rows with nulls. Referencing data frame columns, direct. Syntax is select of name, simplest syntax. Works. Okay, then attribute. By attribute level, df.select, df. First name is correct. Here, column specific operations can be performed like this by doing a COL of that particular column. 1 minute, let's read out this. Different ways to reference columns in a data frame, including direct selection using df.select of name, by attribute using df.column name syntax, only for valid Python identifiers, bracket notation for any column name, including those with special characters, and using the call function for complex expressions, aliasing, and some. You need to perform some. Okay, let's direct representation is like this: select of particular name of that particular column, direct representation by attribute. Only works for column names that are valid Python identifiers, can be referenced across data frame. Example joins. To refer that particular uh, based on the need, I think we need to use this based on the specific need. Column object, you want any any exclusive operation perform on top of that particular column, you can just select and do the column operation. And the expression works with any column name, can be referenced across data frames. Example joins. So in the joins, if you want to use this as a key, the df dot field equals to df dot so and so. So in those conditionalizing specifications in the exclusive way, that time you can use like this. This I don't know what it is, but yeah, we can figure out later. Yeah, you already know alias methods and cast. Is null, is not null, contains. Uh, for example, contains like column little, contains manager. If it, the selection will happen. Ascending and descending, we already know. Default is ascending ASC. If you don't mention, it will take it as ascending. Okay, next built-in functions. Some built-in functions are there. Function operates on columns in data frames. Functions can operate on scalar or complex data types, list or structs. String integers, these are scalar types, and the complex types are list, struct, array, or something like that. Function categories includes math, date time, collection, bitwise, aggregate, window. Different type of functions are there. Can be used both data frame operations and SQL queries using the equivalent function names. Yeah, of course. There is some example built-in functions like round is round in SQL, concat is concat in SQL, date format is date format in SQL, regex replace is regex replace in SQL, and coalesce is coalesce. First non-null value. Okay. Next is user-defined functions. UDFs. Python will not support. Will support, but it will impact the performance as the catalyst optimizer need to optimize into native language. So that's where the performance goes in. You can use UDFs like same at UDF so and so def. You need to define that way, and you need to use that. So that function you need to call that make so with the corresponding input parameters. If you pass and whatever the operations it needs to perform, it will perform. Okay, and allow developers to create reusable custom functions, but can be adversely impact performance as they cannot be optimized by the catalyst optimizer and have additional serialization overhead. Cannot be optimized. Sorry, cannot be optimized by catalyst optimizer. Catalyst optimizer is there, then it will help you to do a better performance. To avoid, it's better to avoid UDFs. Instead of that UDFs, you can use Pandas UDFs. Pandas UDFs allow you to write Python functions that operate on batches of rows instead of single rows. Leveraging Apache Arrow for more efficiency in Python JVM serialization. Okay, most efficient than their non-pandas counterparts. You should still use built-in functions. It is if it is available. Try to use built-in functions as much as you can when you use PySpark. Uh, but if it is not there, then you need to use Pandas. Demo is the ETL framework demo that we are not gonna continue on those lines. So let's summary of this. Okay, and quiz will be there, and I got 18%. See your answers. Let's see my answers, whatever I have given. So for example here, why why is a standard Python user defined function UDF noted to advisory impact performance even though it extends Spark with custom logic. UDF must run Suzy on driver mode. No, it is not. So UDFs cannot be optimized by the Catalyst optimizer and incur additional serialization overhead when converting data between Python and the JVMs. So that's the main problem. This is correct answer. And Spark's lazy evolution model, that is fundamental reason why no computation occurs until an action is triggered. And how does this impact data frame operations in distributed processing? Lazy evolution model. What is fundamental reason why no computation occurs until action is triggered, and how does it impact data frame operations in distributed? Lazy evolution allows Spark to build optimized logic plan and refer execution until complete transformation chain is shown, enabling better optimization strategies. So you know what to do end to end. That way you can able to optimize it later. So that optimization can happen based on the Ishan. Yeah, sorry for the disturbance. Yeah. So lazy evaluation automatically paralyze operations across cluster nodes without user. No, it's not. Lazy evaluation reduces memory usage. No, no. Lazy evaluation prevents corruption. No, it is not. So the only thing is optimized. The plan will be optimized. Logical plan will be there until an action triggers. The plan will be there. What to do? Action triggers. The plan will be full fledged and it will start executing. So that's correct. ETL workflows involving data cleaning and type conversion using DataFrame API. What is the most important consideration for maintaining data quality in distributed processing? Implement consistent data validation and type conversion logic that handles edge cases and null values uniformly across the distributed partitions. It's asking about ETL framework. In ETL workflows involving data cleaning and type conversion using DataFrame API, what is the most important consideration for maintaining data quality and distributed processing? Implement consistent data validation and type conversion logic that handles edge cases and null values uniformly. The main thing, so the main handling of data is comes starting from the null values, and then the type conversion keep them in proper type, and if there is any anomalies in the data, that is the removal process we use. So that's the reason I think, yeah, this is the correct answer. Next is understanding Spark's catalyst optimizer and its role in creating efficient physical plants in crucial for performance is crucial for performance. What is the primary benefit of the optimizer's approach to data frame operations? Catalyst. Okay, Catalyst only optimize SQL queries. No, it's optimize everything. Catalyst only it cannot do UDFs. Remaining everything it optimizes. So that's why you eliminate the answer here. Catalyst optimizer works only with structured data and cannot optimize operations or semi-structured data. No, it is not like that. It automatically increases cluster resources with detecting performance bottlenecks. No. So catalyst transforms data frame operations into optimized physical plans and apply rule based optimization like predict, push down, and column pruning. Catalyst optimizer purpose is like that: column pruning it will do, and predict push down. For example, which task needs to happen at what time, that is a physical plan it maintains. So if you, even though if you, like for example, you did a select operation and you did some operation before the select operation, but select operation should come first, because once you reduce the data, the performance will be more faster. So that's the reason the catalyst optimizer works internally to create this operations into optimized physical plan with better rule based optimization. Predicate push down, which need to which task here. In this case, select operation will go top. As the select happens, only select those rows, they reduce the data, and the processing thing will be better and effective. Okay. When implementing ETL operations using DataFrame API with the flights dataset, what is the primary advantage of using different column reference methods during data transformation workflows? One more time we'll read. When implementing ETL operations using the DataFrame API with the flights dataset, what is the primary advantage of using different column reference methods during that? Hmm, okay. Column reference methods provide flexibility to handle. Column reference means defining the column, schema definition. Schema definition will always help to understand. See, better readability, better understanding on what you're writing is the best way to do ETL operations. So that's what it is says. That's why it says. Okay, each column reference method uses different underlying storage formats for better compression. Different column reference methods automatically optimizes query optimization based on all this. Okay, next, in Apache Spark runtime architecture, what is the primary technical function of the Spark driver? What the Spark driver will do? When is often referred as the brain of the application to analyze the application, construct the tag, schedule tasks, and monitor execution progress. A fundamental concept of Spark data frame. Just a minute. Yeah, so the fundamental concept of data frame lazy evaluation, where the technical implementation of lazy evaluation regarding the execution of multiple transformations like filter followed by select, followed by select. What is the technical implementation of lazy evaluation regarding the execution of multiple transformations like filter followed by select? Data frame operations built upon a logical plan, and the job is only created and computation triggered when action is required. Next, Apache Spark is built upon a shared nothing architecture. Which core characteristic ensures that system-wide failure compacts are impacts are minimized when node encounters an error? Fault tolerance where failures are isolated to individual nodes. Yes, failures are isolated to individual nodes. Resort, I think that is the answer. Yeah, fault tolerance where failures are isolated to individual nodes. Here I did independence. This is wrong. Now, when working with user-defined functions in data frame transformations with the primary performance consideration that distinguishes UDFs and built-in Spark functions. UDFs require serialization between JVM and Python processes, creating performance overhead for sure. That's where it is compared, and of course, this is correct answer. And when navigating the Spark UI Spark UI connect to data frame code with distributed jobs, stages, and tasks. What is the key relationship between logical plans and DAG visualization that helps performance debugging? A DAG visualization shows how Crystal Optimizer transforms logical plans into physical execution stages when dependencies and parallelism opportunities. I mentioned this, okay. The logical plan directly map to individual tasks in DAG without any optimization. Logical plans and DAG visualizations are independent representations use different debugging process. The DAG only shows the data lineage while logical plans shows computational complexity. Logical plan and DAG visualizations are independent. Okay, directly mapped to individual tasks. Logical plans directly map to individual tasks in the DAG without any optimization. Logical plans directly map to individual tasks in the DAG without any optimization. When reading data from external sources like CSV files, schema definition is critical. While schema interface can be used, what technical mechanism provides an alternative that is generally considered more efficient and readable for defining the schema structure, data types, and null constraints? What it does mean. Okay, when reading data from external sources like CSV files, schema defines is critical, of course. While schema interface can be used, what technical mechanism provides an alternative that is explicitly specified DDL? You can specify DDL and call the DDL in it. Okay, Spark optimizes the execution plan through several stages. Yes, Spark optimizes the execution plan through several stages, yes. Which specific engine applies rule based, cost based optimization? It's a tungsten, adaptive query. Catalyst optimizer, yeah, catalyst optimizer is the one. When it comes to rule based and cost based optimization, then it is a catalyst. The shuffle operations is labeled as most expensive operations in Spark, of course. Which type of data frame operation requires shuffle? Because grouping, man, come on, grouping or any key based. Yeah, when saving data frame contents to specified locations after analyzing transaction data, what is the critical factor that affects both performance down and downstream? One minute. When using data frame contents to specify locations after analyzing transaction data, what is the critical factor that affects both performance and downstream processing capabilities? Save all single operations and simply downstream. Okay. choose appropriate file formats, partitioning strategies, and comparison options based on downstream using patterns and query. Of course, this is correct. Next, in the context of analyzing transaction data with data frames, what is the fundamental difference between filtering records and projecting columns in terms of distributed query execution? In the context of analyzing transaction data and with data frames, what is the fundamental difference between filtering records and projecting columns in terms of distributed query execution? Filtering affects row-wise operations while projection affects column-wise operations. Both impact different aspects of data distribution and network transfer. When im- exploring Spark's distributed architecture and mastering the DataFrame API for large-scale data processing, what is the key architecture principle that enables horizontal scalability? Spark, Spark partitions. Yeah, partitions. That's correct. When performing advanced ETL using the DataFrame API, an engineer needs to rename a derived column after a calculation and explicitly cast its data type. Which column reference approach is required to utilize a column object? Column object will help you to do alias casting and all of this other stuff. Next, in Databricks environment, a single Spark job that involves complex transformation, resulting a shuffle operation, will typically consist multiple stages. Yeah. Uh, what uh, what architectural component runs on the worker nodes and it is responsible for executing individual tasks assigned by the driver, cluster manager, executor. When reading external data into a data frame and creating schemas, what is the most critical consideration for optimal performance? Ensuring optimal performance in distributed processing environments. When reading external data into data frame and creating schemas, what is the most critical consideration for ensuring optimal performance? Distributed process exactly define schemas, avoid costly schema definition, of course, obvious. Uh, Spark API operations are organized as transformations or actions. Which of the following operations are classified as an action because it triggers the execution of the file execution plan? Count. Yeah, this is the correct answer. Yeah, let's end this session here and yeah, thanks for watching my live stream.